So let's start with chapter 2.3, which is inside the matrices section, and 2.3 is called Linear Systems of Equations and Gaussian Elimination. So linear systems of equations are one of the oldest problems in mathematics, solving a linear system of equations. Yeah. So I think the ancient Chinese were already showing methods for solving this in ancient textbooks. It's also one of the most common problems in physics. So many equations in physics are linear equations. For example, Maxwell's equations of electromagnetism are linear. The equations to solve a circuit, if you don't have diodes or nonlinear elements, so you have resistors and so on, this is a linear system of equations. You also found in previous chapters that, for example, to write a vector in a different basis, you could write a linear system of equations to solve it. Or to solve the null space of a matrix, you had to solve a linear system of equations, A times X equals 0. So there are many cases when you have to solve a linear system of equations. And in the past, what you have done is you write your equations, and then by trial and error, you start subtracting one with the other, or multiplying one by 2 and adding it to the other one, and the result you substitute it in the other. So more or less, that works very well, especially if you have two equations with two unknowns. But what if these things start getting messy? 3 equations with 3 unknowns, 4 equations with 4 unknowns, and so on. Then it's good to have a method to solve it. So a fixed algorithm that you could tell a computer to do, or you could do yourself, knowing that you will always get a correct result. And this method is Gaussian elimination. And I really like this method because when you do Gaussian elimination, not only you solve a linear system of equations, but you also gain a lot of understanding about the linear transformation A that is involved in this system of equations. So you find things like what is the nullity of the matrix, the rank of the matrix, all comes automatically. It all pops out in front of you after you have done Gaussian elimination without almost having to think about it. So it's a very useful method. Once you learn Gaussian elimination, you can actually go back to chapter 1, equations of lines and planes, and you can redo some of the problems using Gaussian elimination. You could go back to 2.2, calculating of range and null space, and solve some of the problems doing Gaussian elimination. You could go back to 1.2, n-dimensional vector spaces, where we were solving linear systems of equations to write a vector in different bases, or to check if vectors are linearly independent. All of that you can do using Gaussian elimination. So I hope you enjoy this chapter, and see you in the next video.